Hello everyone, welcome you all. Let's start our discussion and solve the physics question paper of Mrft Odisha 2024. As you know, there are two sections, section A and section B. Section A consists of the general studies and section B consists of physics question paper. So here we will solve the physics part and there are total of 70 questions. So today in this video we will solve the first 35 questions. Okay, let's start. Question number 31. The shape of the phase space trajectory of a one-dimensional harmonic oscillator of mass m and force constant k is. Okay, so from here you can write the total energy for the one-dimensional harmonic oscillator as p square by 2m plus half k x square. So from here you can write p square by 2m e plus x square by 2 e by k equals to 1. So this will give you the equation of ellipse. So the shape of the phase space trajectory here will be ellipse. Okay, next. Question number 32. Which of the following expression represents the legendary polynomial p for x? Okay. So you should remember this. For legendary polynomial, p0x is 1, p1x is x, p2x is half, 3x square minus 1, p3x is half, 5x cube minus 3x, and for p4x is 1 by 8, 35x to the power 4 minus 30 x square plus 3. Okay, so you can check here A is your correct option. Next, an electromagnetic wave of angular frequency, sorry, it is not visible. Next, an electromagnetic wave of angular frequency omega propagates in a plasma of plasma frequency omega p. If k is the magnitude of the wave vector and c is the speed of light in vacuum, then so this is, you should remember, omega square minus omega p square equals to c square k square, or from here omega square will be omega p square plus c square k square. Okay, so your correct option is option A. For one-dimensional motion of a particle, if x and p are the position and momentum operator respectively, the commutator of x cube p is equals to. Okay, so here x cube p. Okay, you should remember for any two operators, the commutator bracket a n b is equals to n a cap n minus 1 a b n minus 1. Okay, so here 3 x square xp and xp we know I h code, so it is 3x square I h code. So C is your correct option. Next, question number 35. If J is the rotational quantum number of a molecule, the selection rule for Raman scattering is, and that is del J equals to 0 plus minus 2. Del J equals to 0 for your Rayleigh scattering, plus 2 for Stokes lines of Raman scattering, and minus 2, del J equal to minus 2 for anti-Stokes lines of Raman scattering. Okay, so your correct option is option D. Next, question number 36. A particle of mass m and electric charge q moves with velocity v in a plane perpendicular to a uniform magnetic field B. The particle moves in a circular path of radius r with time period equal to. So you have to find the time period. Okay. See, this is very general problem. So you should remember this directly. Okay. Otherwise, you can calculate. Like here, you can see as a charge particle is moving in magnetic field, so the force will be Q Vb. Okay, and this force is equals to, as it is moving in a circular field, so this will be equals to the centripetal force, that is mv square by r. So from here you can find r is equal to mv by qb, that is the radius of the circular motion of the charge particle. But here it is asking to find the time period. Okay, so time period is equal to distance by speed. Okay, distance here is the 2 pi r by v, and r we have 2 pi m by qb. Okay, so the time period will be 2 pi m by qb. So D is your correct option. You should remember this expression. Okay, these are very important formula. Okay, like the radius of the charge particle moving in a magnetic field in the time period. Next, question number 37. The reciprocal lattice of FCC lattice is BCC. Similarly, you should remember for all, like for simple cubic, reciprocal lattice is simple cubic. For BCC, reciprocal lattice is FCC. For FCC, reciprocal lattice is BCC. Okay. Next, for HCP, reciprocal lattice is HCP. Okay. Similarly, related to this, they sometimes they ask about the atomic packing fraction also. Okay, so you should also remember that for simple cubic it is 52% or pi by 6. For BCC it is 68%, that is root 3 pi by 8. For FCC 74% or root 2 pi by 6. For HCP also uh, this is packing fraction is 74%. Okay. Next, for diamond cubic, it is 34%, and the expression is root 3 pi by 16. Next, if B is the baryon number, S is the strangeness, Q is the electric charge, and I3 is the isospin projection for an elementary particle, the Kalaman-Nishijima formula relating these is. Okay. So here you should also remember this Q equals to I3 plus B plus S by 2. Okay. So here is the correct option is option A. Okay. So here this B plus S is represented as hypercharge. Okay. Hypercharge. Sometimes they also include the charge quark. Okay. So you should remember Q equals to I3 plus B plus S plus C means charm quark. Okay. B plus S plus C by 2. Okay. So this will be the complete formula. Next, the number of generators of the SU2 group is equal to, it is 2 to the power n minus 1. Okay. So that will be 2 to the power 2 minus 1. Okay. So it will be 2 to the power 1. That is, so your correct option is B. Next, question number 40. In a two electron atom, the orbital quantum numbers of the electrons are L1 equals to 1, L2 equals to 2 respectively. Using the LX coupling scheme, the possible values of the total angular momentum quantum number J are. Okay. So see, J we basically define from L minus S to L plus S. Okay. So here first you have to define L and S. Okay. L is defined from L1 minus L2 to L1 plus L2. See. And S from S1 minus S2 to S1 plus S2. Okay, so for given L1 is 1, L2 is 2, so L value will be 1, 2, 3. Next, S value will be 1. S1 is S1 is half, S2 is half, so S value will be 0 and 1. Okay, so now from using this value of L and S, J value will be 0, 1, 2, 3, 4. Okay, so your correct option is option C. That is 0, 1, 2, 3, 4. Next, question number 41. A charged particle moves at non-relativistic speed with a constant acceleration a. The total power radiated by the particle is. Okay, so proportional to how it varies with acceleration. Okay, so you should remember for a accelerator charge particle, the power is given by mu naught q square a square by 6 pi c. So here power is varies as a square. Okay, so here correct option is option B. Sometimes they ask with the oscillating dipole also. At that case, power will be proportional to frequency power 4. Next, if alpha is the fine structure constant, the fine structure correction to the energy of the hydrogen atom is proportional to. So you have to find the fine structure correction to the energy of hydrogen atom. Okay. So you should remember this is varies as alpha square m is c square. That means basically alpha square here. Okay. So there are other variation with fine structure constant. You can remember for hyperfine structure. Okay, for hyperfine structure, this is varies of the order of alpha to the power 4 m is square c square by mp. That means there will be variation of alpha to the power 4. Next, for lamp shape, the variation is of the order of alpha to the power 5 m is c square. So you can remember this. Next, question number 43. Einstein's coefficient A is related to the A is related to the spontaneous emission. Okay, actually we know there are three coefficients. Okay, one is the stimulated absorption. Okay, second one is the spontaneous emission, and the third one is the stimulated stimulated emission. Okay, next, first one is the stimulated absorption. So like you can say initially there is particle in the ground state. Now by absorbing a photon, it is going to the excited state. Okay, so here the Einstein's coefficient is B1, 2. Okay, next is the spontaneous emission. So initially the atom is at the excited state. Now by radiating a photon, it is coming to the ground state. Okay, so here is the Einstein coefficient is A 2, 1. Okay. Next, stimulated emission. So by absorbing a photon, it is coming to the ground state by releasing an extra photon. So here the Einstein coefficient is B2, 1. Okay. So coefficient A is related to the spontaneous emission. Okay. There is also relation between these coefficients. You should remember that B12 by B21 equals to 1 and A21 by B21 equals to 8 pi h nu q by ck. Next, the phase space coordinates qp are transferred to the coordinates qp. Which of the following transformation is canonical? So to find this, you can use either Jacobian relation or canonical Poisson's bracket relation. So for canonical transformation, the Poisson's bracket will be 1. Okay, now you have to check with each option which will give you the Poisson's bracket value of 1. Okay, Here you can write this as dq by dq dp by del p minus del q by del p small p into del p by del q equals to 1. Okay, so you have to find this expression. Okay, so let us check for the option A. Okay, so for option A, you can put like del q by del q. So it will be half 1 by square root under q cos 2p. Okay, now del p by del p. So this will be square root under q 2 cos 2p minus. Okay, you can see here 2 square root under q. 2 square root under q cancel. So it will be basically cos square to p. Now from these two terms, okay, del q by del p. Del q by del p, that is square root under q cos p will be minus sin 2p. So it will be plus. So sin 2p and here will be 1, 2. Okay, from derivative. Now del p by del q. Del p by del q. Okay, so again it is half 1 by square root under q 2. Sorry, this will be sine 2p. Okay, so 2 square root under q, 2 square root under q cancel. Sine 2p will be plus sine square 2p. So this cos square theta plus sine square theta is 1. Okay, so this option A is satisfying the Poisson's bracket with value 1. Okay, so this will be the canonical transformation. Next, 45. In a laser beam, if lambda is the center of wavelength and del lambda is the width of range of wavelength, the coherence length is proportional to del square by del lambda. Okay, so your correct option is option B. Next, 46. Which of the following is not correct for quasi-crystal? For quasi-crystal. Okay, they can be alloys of aluminum. Yes, this is correct. They cannot have high-fold symmetry. Okay. Okay, comes to the option C. They cannot have translational periodicity. This is also correct. They cannot have eightfold symmetry. This is correct. And this is not correct about quasi-crystal because you should remember crystals, how we define, they will be having periodic arrangement, periodic arrangement. They are not having five-fold, sevenfold symmetry. But these quasi-crystals have no periodic symmetry. Okay, and they are having fifth fold, seventh fold symmetry. Okay, so this option is not correct. Next, which of the following is not necessary for a group? Okay, so out of these four, you can see commutative property is not necessary for a group. Okay, but if a group is having commutative property, then that will be called as abelian group. Abelis, abelian group. Okay, so which of the following is not necessary? That is your commutative. Option D. Next, 48. For which of the following HKL planes in a BCC lattice does the diffraction intensity vanish? Okay, so we know for simple cubic, all HKL values are allowed. For BCC, H plus K plus L should be even, and for FCC, HKL either all even or all odd. Okay, so if for BCC, if H plus K plus L value is odd, then the diffraction intensity will vanish. Okay, so you can check from the option this 113 for 111, that is your correct option is option C. For this, diffraction intensity will vanish for BCC lattice. Okay, next 49. Tunneling of paired electrons from one superconductor to another superconductor across a thin barrier is called, this is your Josephson effect. Okay. Here, related to the superconductivity, you should really revise the concept of Cooper pair. Okay, Cooper pair. All concept related to this, like they behave as the bosons. Okay, so spin, and they followed the Bose-Einstein statistics. Okay. Next, question number 50. The Laplace transform of sin t by t is. Okay. See, this here you have to use the property of Laplace transform to solve this. Remember, if Laplace transform of f of t is f of s, okay, then Laplace transform of f of t by t will be s to infinity f of s ds. Okay, f of s ds. Okay, here our f of t is sin t. Okay, and we know Laplace transform of sin at is given by a by a square plus a square. Here a is 1, so the Laplace transform of sin t is 1 by 1 plus a square. Now Laplace transform of sin t by t, that is s to infinity 1 by 1 plus, sorry, 1 plus a square ds, and we know integral 1 by a square plus x square dx is tan inverse x by a. Okay, tan inverse x by a. So here you can write tan inverse s by 1, that is tan inverse s. Okay, now put the limit 0, sorry, in s to infinite. Okay, so that is your tan inverse infinite minus tan inverse s, and tan inverse infinity is pi by 2 minus tan inverse s. Okay, now here you should remember two relations, like tan inverse x plus cot inverse x is equal to pi by 2. Okay, and tan inverse x plus tan inverse 1 by x equals to pi by 2. So using this second relation, you can find tan inverse 1 by x equals to pi by 2 minus tan inverse x. So here we can write this is tan inverse 1 by s. Okay, so your correct option is option B. Next, 51. A complex function is given by f of z equals to z to the power 6, z square plus 1 to the power cube. The points z equals to plus minus I are simple poles of order 3, 6, and 2. So let us find here z square plus 1 equals to 0. Here you can, by looking at this, you can say these are the poles of order 3. Okay, so let us find z square plus 1 equals to 0. So z square is equal to minus 1 and z equals to plus minus I. Okay, so these are the poles of order 3. Next, 52. A homogeneous cube head has mass m and side L. The sides of the cube are along the three coordinate axes, and one of the corners is at the origin. The cube rotates about an axis passing through the body diagonal. The diagonal elements of moment of inertia tension are given by, this will be 2 by 3 ml square. Okay, this is your correct option. Similarly, you should remember moment of inertia for different objects. Okay, like for rod, moment of inertia of rod about an axis passing through its center, it will be ml square by 12. About its end, ml square by 3. Similarly, for circular ring, axis passing through its center will be mr square. About its diameter, it will be mr square by 2. Next, for a disk, moment of inertia about an axis passing through its center will be mr square by 2. About its diameter will be mr square by 4. For solid sphere, it is 2 by 5 mr square. For hollow sphere, about an axis passing through its center. Okay, 2 by 3 mr square. Next, similarly, you should remember for hollow cylinder and solid cylinder. Okay, about both axes, like about this axis and about this axis. Okay, for hollow cylinder, it is mr square, and about this axis, it is mr square by 2 plus ml square by 12. Similarly, for solid cylinder, about this axis, it is mr square by 2, and about this axis it is mr square by 4 plus ml square by 12. Next, 53. At very low temperature, the lattice heat of a solid is proportional to. So the specific heat here is proportional to the cube of the absolute temperature. Correct option is option B. Next, 54. The diameter of Earth assumed to be spherical and of uniform density is suddenly doubled, with the mass remaining unchanged. The weight of a body lying on the surface of Earth. Okay, so weight is given by m into g, and small g is defined as capital G m by r square. Here, g is constant fixed, m is remaining unchanged, only the diameter becoming double. So its diameter is double, so radius will be double. So here we can write m times gm by 2r square. That means 1 by 4 gm by r square. So the weight of the body will decrease by 4 times. Okay, so D is your correct option. 55. The magnetic induction B in a given region is uniform. The magnetic vector potential in the region is given by A equals to half B cross R. Okay, so this is your expression for the magnetic vector potentials. This is your option C. Next, 56. A particle of mass m is trapped in a one-dimensional infinitely deep potential well of width L. The energy eigenvalues of the particle are proportional to C. Energy eigenvalues are given by n square, pi square, h cot square by 2m L square. So this is proportional to 1 by m L square. So your correct option is option C. Next, 57. An unpolarized monochromatic electromagnetic wave is incident on the boundary of two different non-conducting media with the angle of incident equals to Brewster's angle. That means unpolarized light will be get the reflected ray will get polarized. The electric field of the reflected wave will normal to the plane of incidence. Okay, so here you should remember that if a unpolarized light, okay, having both components parallel and normal to the incident plane with a angle, incident angle, here is the Brewster angles. Okay, now the reflected ray will be normal, that will contain the components normal to the plane of incident, and it will be fully polarized. And the transmitted ray will be partially polarized containing both components. Okay, so here this is your theta r reflected angle, this is your theta t. Okay, so here one more concept you should remember, the theta r plus theta t will be 90 degree. Theta r plus theta t will always be 90 degree. Okay, and this is also 90. Next, 58. The Paschen-Work effect is the splitting of atomic energy levels in the presence of very strong magnetic field. Okay, and in the presence of electric field, that will be Stark effect. Okay, Stark effect. Next, the spectroscopic term for the ground state of sodium atom is, okay, you see spectroscopic term is given by 2s plus 1 L J. Okay, so for ground state of sodium atom, you can write sodium 11. Okay, 1s2, 2s2, 2p6, 3s1. Okay, so here this is your S, because S means small value is 0, that is your S. Now spin is half, this will be 2. Okay, so and J will be L plus S, that is 0 plus half will be half. Okay, so this will be half. So 2s half. So this is your correct option, option D. Next, 60. Simpson's one-third rule gives the exact result of the integrand. Is the integrand is a polynomial of degree 2. Okay, so your correct option is C. Next, 61. In a Hall experiment, if J is the current density, S is the magnetic intensity, E is the Hall field, the Hall coefficient RH is equals to. So for RH, you should remember all the relation, like RH is 1 by NE, RH is E by JB, and VH here is IB by NET. Okay, so from here you can see RH is E by JH. So this is your correct option. Next, 62. The dimensions of Planck's constant is equal to the dimension of angular momentum. Okay, you can directly write this like from Bohr's atomic postulates. We know angular momentum is given as the integral multiple of h chord. That means, and you should remember from dimensional analysis, the equation is valid only if the left hand side and right hand side having the same dimension. So here, from here you can say the Planck constants is having the dimension of angular momentum. Okay, next. The mean of Poisson distribution is equals to m. The variance is, okay. So for Poisson's distribution, you should remember the mean and variance are the same. Okay, so the answer will be m. So your correct option is option D. Next, 64. 64. Next, 64. A particle moves in a real potential Vx if lambda x is the de Broglie wavelength of the particle. The condition for the validity of WKB approximation is the variation should small, that is a del lambda by del x should be less than 1. This is your correct option. Option B. Next, 65. If alpha 1, alpha 2 and alpha 3 are the direct alpha matrices, then alpha 1 plus alpha 1, alpha 2 plus alpha 2, alpha 1 is equals to 0, because you should remember this direct alpha matrix anti-common. Okay, this direct alpha matrix anti-common. Okay, so this value will be 0. Okay, let's stop here for now. We will continue from this point in the next video. I hope this session will definitely help you in your exam preparation, and if you found this video very helpful, don't forget to like, share and subscribe to our channel. Thanks for watching and see you in the next